All right, hello, how's it going? So at the moment we've got this scene, just load up, have a look at it. And we have a number of different meshes, different models that we've got. But the issue is that we keep loading in new ones. The render encoder is jumping around and doing a bunch of state changes. And it's not really the optimal way to work with these. So what I'm going to do is I'm going to load all of these models together into one mega model, menagerie of models, if you will. And then I'm going to load that in one go. And when I draw, I'm just going to draw different regions of that. So this will also involve moving away from model IO. So in previous videos, we're using model IO to load models. It does a pretty good job, but I'm not going to use that. So let's just close this down. And there's a number of steps, but the first step is if we look at view, let's go to the object mesh, and I'm going to rewrite all of this. Actually, before I rewrite this, I'll just grab this stuff here. Let's grab that. Actually, I changed my mind. I'll just comment it out. And yeah, we'll get to it later. Okay, so what I want to do is I want to set this up so that instead of just loading from file with model IO, I read the file as a text file, get the data. So I'm going to need a few things. First of all, I'll need to store all of the vertex information. That should be an array of vertex. So if we go to definitions.h, we've got this vertex definition. I'm just going to modify this. I'm going to add in the texture coordinates. Yep, so we'll have a whole bunch of those, but also we'll have some state which will be populated as we read the text file. So I'm going to want the vertices. And the texture coordinates. I'm also going to keep track of the position that we're reading in the file. Yeah, okay. Fair enough. Okay, so what are we doing here? Let's go through this. Yep, we're grabbing the URL to the resource. I guess we don't need the mesh buffer allocator. We just need the file name. Okay, so we've got the URL to the resource, and what I want to do is load the file, basically. So that's why I'm doing this, putting this in a do block, because it's possible that we weren't able to open the file. So if we're not able to open the file, no worries, we'll just cause an error. Okay, no worries. And I'm just gonna get rid of all of this. Okay, so now what I want to do is open this up and start reading it. Okay, so what we do is first up, we just initialize this, just take all the contents of the file and set that to a string, or load that in. And then we don't want a big like blob of string text, we want the individual lines. So we'll split them, separated by new line, and that will give us a whole bunch of things that we can read. So now I'll just go read through. Okay, so that this makes sense, I'll just open up there we go. Oh, okay. Anyway, so just so this makes sense, I'll just have that model file open there. So what I've done is, first of all, I have loaded in all of this as one file. Then I broke it down into individual lines. And then if we look on an individual line, each individual line has a bunch of arguments, but they're all separated by spaces. We have v space all this data. Again, even here we have something, but it's separated by spaces. So that is why I want to separate them according to space. But then I want to look at the first component of each line and make a decision based on that. So I'm going to run a switch statement based on the first thing I see on the line. And the options that I'm really interested in are v, vt, and vn. If I see a v, then I want to write some data to the vertices set. If I see vt, I'll write to the text coordinates, and so on. We also have f to declare a face. That's pretty important. So anyway, I'm just going to leave this right now and go down and write a few extra functions. Okay, so that's the v, vt, vn, and then we need the face. I might as well look at this bit as well. So if we were to read the face data, that would be this line here. We want to split that off into the individual pieces. That's this piece here, this piece here, this and here and here and here. And each of those describes a vertex or a corner. So I'm going to make another function called read corner data. And all of these are a little bit similar. They basically take some sort of list of strings and use them. So what about the vertex data? Well, here's a line. What we really want to do is grab v0, v0, component 0 is the v, components 1 is the x, components 2 is the y, and so on. So what we want to do is append to our set of vertices And there we have it. Very simple function. We just there we go. Okay, awesome. So I can take that, and these ones will be very similar. Okay, face data is a little more complicated, so I'll just go back to the original function, jump back to these, call these, and then have a look at face data. So for the face data, I want to start looking at these cases, not the face data, I mean everything else. And there we have it. Now it says here, switch must be exhaustive. So we'll give it a default, which is simply to break. Okay, so I'll just go through these cases here. So we have V. So again, if we see VT, read text chord. If we see VN, we'll read normal data. And then finally, if we see F, we'll read the face data. Okay. Right, so onto the faces. So by default, or the way OBJ files work, these faces are in sort of a triangle mode. So if I call this face 0, 1, 2, and 3, this breaks down into two triangles. The first triangle involves points 0, 1, and 2. The second triangle involves points 0, 2, and 3. So the way we handle this is, first of all, we need to know how many triangles does this set represent. And it turns out the number of triangles is always the number of points minus 2. But I'm actually going to subtract 3 because this components variable implicitly, well, it includes that f there. So I'll go triangle count. That'll be an integer. Go components count minus 3 again, minus 2 just mathematically, and then minus 3 because there's also that tag there. Okay, so then I want to keep track of which triangle I'm constructing. So for instance, here we have two triangles. So I'll start off constructing triangle 0, which will involve these first three. And then I'll have triangle 1. Now I always know I'm going to include this point here, but then the question is, do we include, what am I thinking? If we know that we're making triangle 1, then we know that it will be these last 2 points, for instance. Does that make sense? I don't know if that makes sense. But let's just go, well, the triangle that we're working on is less than the triangle count. What am I thinking? Okay, so I want to go components 1, always. That's always this point here. We're going to run into trouble because I misnamed this. Let me call this description. Okay, so this is corner A, if you will. Then I need to work out corner B and C. So again, I want to set this up so that when I'm getting triangle 0, the first triangle, it's just the points 1, 2, and 3. 1, 2, and 3. but then I want to set it up so that while this first point is always the same, the next points are shifting along. So yeah, that works. Yeah, okay, cool. So now I'll just go down to, well, of course, we should always increment the triangle. And there's something I missed up above. We should be incrementing the cursor. Okay, anyway, so down below to the corner function. So imagine I get this point here. We have a bunch of arguments in integers separated by slashes. So let's go ahead and separate that. And then that will give me the individual arguments as strings. Now these are referring to the vertex, vertex texture, and vertex normal from the set which were defined above. And here they're actually 1 based, but they should be 0 based in order to get into our arrays. So we'll have to correct for that too. But let's go. We'll make a vertex. And then we'll populate that. First of all, we need the position. There we go. So we take the first thing of that split list, convert it to an integer, but then we'll just need to subtract 1 to correct for that 0 based indexing. Okay, so I just realized I'm gonna have to adjust this. Let's go back to definitions, and something I missed here. Oh, why did I call that color? Maybe that was what it originally was. I'm also going to change this to float 4. There we go. Yeah, because I want to include that 1 there. Okay, so where was I? So for the position, what I'm going to do is I'm going to construct a float 4, putting in a 1 on the end. Now the rest of this should be fine. Okay, cool. So fingers crossed, when each of these is constructed, it will end up with a list of vertex structs with the appropriate position, UV, and normal set. Okay, so this is all well and good, but if we go back to our renderer, we've got some errors, and some of them are easy enough to fix. For instance, here, and that's all fine. All it was complaining about was that it had all these extra arguments that it didn't need. Okay, then down below, it's saying it doesn't really know what this vertex descriptor is, and that's the stuff that I commented out. So let's grab that and use it. Okay, so just double checking here. So we're creating a vertex descriptor. Let's go. But otherwise, I think the rest of this is fine. Okay. Great. So now we can just use that directly here. So what I'm doing is I'm just, okay, now over here, although I've nicely formatted the code, it is complaining. Now this is code that I've written, so I can go back and alter it. The problem is we're expecting, in the pipeline builder, we're expecting that vertex descriptor to be a model vertex descriptor. We can just change it back to a metal vertex descriptor and then get rid of this line here, so we don't need to convert it. It is in the format we expect. Then we pop back and confirm, give it a second. Okay, excellent. Cool. So again, what we're doing is we're loading all of this in, and then we are, let's double check, yep, specifying the vertex descriptor for the pipeline. And yeah, it's very nice. We can now just get rid of this example model file and put this back to full size. All right, so what I've done is I've loaded in a bunch of different meshes. I want to combine them into one. So I'll just create a new file, just go to view, right click, new file. Yeah, Swift file, that's the one. And I'll call this Vertex Menagerie. That's it, that's a collection of vertices. It's a Vertex Menagerie. Okay, so what will we need? Well, we'll basically need to track the first vertex and the vertex count for each model. Think of each model as occupying some range on this larger set. But I'm also going to need to keep a track of my playhead, where I'm up to. So I'll start with that. I'll call this offset. We'll have the first vertices, and that will be a dictionary. The key type will be an integer, and the value type will be an integer. Okay, so the purpose of consuming models is to build up a large set, a large array of vertices. So there we've got it. And then what I'm going to do is I'm going to bounce that down to a vertex buffer. And I am going to use a buffer. I'm not going to use a mesh with attributes. Maybe later on. I don't know. Yeah, let's also import metal kit so we know what a metal buffer is. Okay, so there are two functions that I'm going to have. I'm going to have a consume function and a finalize function. So first of all, the consume function. So first of all, I'll just record the first vertex and the vertex count. And I'll record the first vertex as the current offset. Obviously for the first model, it's going to be 0, but then as some data is recorded, that offset will be incremented. And so every time it will be set at the correct position to begin working on the model. Okay, so what I'm doing here is just grabbing everything which is on the buffer, and then right, so this will just be accessing the number of vertices which was just written, and we'll increment the offset by that much. Cool, so that's all we do. We basically record, append to our large lump, and then increment our internal counter. So then we have the finalized function. And for this, we'll need device. And really all we need to do is set up that vertex buffer. And luckily we have the make buffer option, where all we need to do is pass in the data set that we just have been populating this whole time, and then tell Metal how much stuff to read from there. So we'll go number of things in data times the size of a vertex. Okay, cool. So if we call this function, the vertex menagerie should be created. So we can just pop back to the renderer, and I'll just put this up here for now. We'll go create that, and then I'm actually going to get rid of these declarations here. So then what I'll do is I'll go okay, so I'll consume that, and I'll just say that's mesh type 0. So basically, these are really short-lived objects. We just load the file, read it. But after loading everything, we need to finalize it. Okay, yep, so there we have it. But while I was setting this up, I've now set it up so that I'm creating a buffer and passing that in. And it's going to need a bit of work on the shader side. So what I'll do is just open up both of these shaders. It'll both go the same way. And I'm just going to get rid of this vertex in. Before I was using these attributes, I'm not creating attribute descriptors at this point. What I'll do is instead I'll declare this as a buffer. So I'll create an array, and I'll declare this as, well, I guess buffer 0 isn't being used in the vertex shader. No worries. So what I'll also need is the vertex ID. Go ahead and access that, and just change this to UV, and the rest of this should work fine. So I'll head to the unlit shader and do the same thing. So I can pretty much just copy this, get rid of the vertex unlit, and I'll do the same thing down here. Okay, cool. Now just quickly double check. Yep, the shaders are fine. Okay, let's just close these ones down, and we still have, we should have a whole bunch of errors here in the renderer. So let's go down and see what the errors are. Okay. So first of all, I'm going to simplify this. I'm not going to, well, even before that, let's get rid of this send camera data function, because the camera data has already been sent when we were drawing the lit objects. Just as a refresher, the way this works is when we draw, first of all, we draw the lit objects and then we draw the unlit objects. So the camera data has already been sent in this function up above. And I know that we could be saying, well, we've got a different pipeline state that we're working with. Maybe we need to send the data once for each pipeline. Turns out, no, we can just send it once and it works. So that reduces the overhead a little bit, so that's nice. But then I'm just going to take this top from bottom. So what I'll do is set vertex buffer, and the buffer I'm going to send is the menageries buffer. The offset is 0. We're going to start from the start. The index is 0. Remember from the shader, it said that was buffer 0. So anyway, back to this arm for drawing. Now, really, this is just arm that material for drawing, not the texture. And I'm gonna change. I should just go down to the arm for drawing. Okay. So I'm not going to take a mesh. And so this part here, I can just I'll get back to that later. Okay, so where was I? Over here. Now instead of this, I'm going to take a mesh type. Now for the cube, that'll be 0. I'm almost drawing these models. Well, I'm drawing them in exactly the same order that I loaded them. That's fine. Okay. So where was I? Okay, great. So the arm for drawing function is fine. The issue is just dealing with the draw function. So if we go into the draw function, right down below, we have this big loop thing. Let's not do that. So instead, we'll simply draw primitives. And while I'm at it, I'll just change this. So I will take an integer for the mesh type. So now those errors above should go away. But anyway, so the primitive type here will be triangle. For the vertex start, we'll look at our menagerie. First vertices for that mesh type. There we have it. So let's give this a go, see if it works. It should work. I'll be annoyed if it doesn't. Uh-oh. I think a while ago I made a video on this, programming hints, programming tips, how to learn it. And one of the things I said is if you write a whole bunch of functions and then you get an error, there's a pretty strong chance that the error was like the first thing that you wrote. So I ran this a number of times and it kept failing. So I clicked down below to open the terminal, open the console, and it says here, assertion, we can't create a buffer of 0 length. So why is it trying to create a buffer of 0 length? Clearly, the stride of the vertex is non-zero. So it would appear that the data has got 0 things in it. Well, why would the data have 0 things in it? I mean, we're appending. Well, as it turns out, if we go back to the object mesh, and by the way, we can get rid of this stuff that we commented out. I'm happy with that. That should be working. Right down the bottom here, when we read the corner data, we populate a vertex. We don't do anything with it. That's not good. So let's go data, append, vertex. There we go. Am I not calling that data? Oh, buffer. Okay, fair enough. Okay, so now we should have buffers of non-zero size. Let's give this a go. There we have it. Maybe not super exciting because, well, it looks the same, but it is a little more performant because it's all coming from the same buffer. Anyway, so that's it. Hope you had fun, and oh yeah, I'll see you again soon. All right, bye.